So, good morning, everybody. Good morning from Central Europe because we have morning. Hello, everybody in the world. Welcome to our session, Digitalization in the Forest Sector. I will be the moderator. My name is Thilo Wagner. I am the principal of the Forest Education Center of the States Forest Service of North Rhine-Westphalia. And the reason why I'm here is because Forest Europe is supporting this event, and I'm the German representative in the Forest Europe expert group, Green Jobs, Education, Forestry and Training Systems. The technical development, like the digitalization, is changing very rapidly. The speed of technical progress is getting faster and faster. The time gap between these two global events, the death of Pope Johannes Paul II and the retirement of Pope Benedict XVI, is less than 10 years. And it would be interesting to discuss how a picture of such a global event looks today. Our world is changing and forestry is transforming as well. The digital transformation changes and changes in forestry. We call it Forestry 4.0 or Forest and Timber 4.0, or because we don't not have the steps in forestry of the four industrial revolutions, the invention of the steam machine, the mechanical production with water and steam, the electric-powered assembly line mass production, automation with electronics and computer robots, and the fourth step, the Internet of Things. Digitalization in forestry is a major step causing central questions. How do digital applications and technology affects the future tasks and activities in forestry, the skills and abilities of people working in forestry, and the knowledge transfer. In our session, we want to find answers for these questions. Four speakers with different perspectives and best practices for facing the challenge of implementation digitalization in the forest and timber supply chain. This is the overview. We have four interesting contributions all over Europe. And we will start now with the first presentation. And the first presentation will be a good best practice about implementation strategies for forest and timber, the Center of Excellence for Forestry. And the presenter will be Frank Heinze, which is the coordinator of the Competence Center Forest and Timber 4.0 from RIF Institute for Research and Transfer from Dortmund. So I think now, Frank, the stage is yours.
Thilo, thank you. I will try to share my screen first. Let's see. Okay, you should be able to see it now. Yeah, welcome from Germany, welcome from Dortmund. Thilo Wagner already mentioned it. My name is Frank Heinze. I'm a project coordinator of the Competence Center Forest and Timber 4.0, and I would like to talk about infrastructure and why digitalization needs infrastructure. Well, in this first picture, you already see that we in our sector, in the forest sector, we have a lot of different data, lot of different types of data. And if we want to work efficiently, we need to process this data and bring this data to the people that are really interested in it. The project I'm presenting was supported by the European Regional Development Fund and by the Ministry of North Rhine-Westphalia. Okay, let's have a look. Motivation, infrastructure and forestry 4.0. So why forestry 4.0? So in our sector, in the forest sector, we usually have numerous actors. This means there are usually a lot of people involved. So the structures, they are usually pretty heterogeneous. So we usually do not have, at least in Europe, like one value chain, but if you look in different places, things are organized quite differently. On the other side, our sector, in my opinion, is pretty innovative, and there is already a lot of digitalization approaches. So you will find out of some in this workshop here. But often these approaches are not interconnected. And so what is really missing is an end-to-end digitalization of our value creation processes. And the answer, in our opinion, is approaches derived from Industry 4.0, approaches from the Internet of Things, and we would like to transfer this to the forest and wood sector. So, digital communication infrastructure, what do we understand by this? Now it's getting a little bit more technical, so be prepared. So usually in our sector, we have very different type of actors. We call them assets. So these are people, machines, forest stands, companies, sensors, and so on. And some of them, they do not have a connection to any type of digital infrastructure. So we propose to add so-called digital twins to all of these assets. And when we combine an asset with its digital twin, it becomes a Forestry 4.0 component. And this is not self-sufficient. We also need like digital services, well, for optimization, control, forecasting, and so on. And human-machine interfaces, so that the human actually is possible to interact with these systems. And why do we do this? Actually, we would like to improve important tasks we do have in forestry. So find solutions for different application areas like forest management, like harvesting, forest information, wood mobilization, and so on. So how can we do this? I mean, if we have our digital twins and our assets, our services, and our man-machine interfaces, so there should be a way to actually, so that one digital twin can find another digital twin it can actually interact with. And we also make sure that authentication is correct, so that we are actually talking to the one we actually would like to talk to and not someone else. And we proposed a system that's called S3I, Smart System Service Infrastructure. And currently, I will not go into every detail here, but what we think will be the future in this system is actually to go a step further. In Europe, we are actually at the moment building up a digital infrastructure that's called Gaia X. And this Gaia X infrastructure might provide us the backbone to actually develop data spaces, develop services, and actually to get our digital infrastructure up and running, so that basically everyone can use it and everyone can interact with anybody else in our sector. So this was for the for the technical part and now have a look at some applications for it. So if we'll build up such a digital infrastructure, we'll also need some test and development. Well, we can call this also infrastructure for our Forestry 4.0. And in our competence center, we provide the so-called smart forest labs. We have like three different variations of smart forest labs, so real, gamified, and virtual. And we will have a look at the gamified and the real smart forest labs. So let's begin with the gamified smart forest. Well, what a difficult word. Gamified smart forest lab. Why a gamified smart forest lab? So this is just a model of a forest stand in Germany, in Arnsberg, to be precise. And this model actually models real machines, real devices, and it also uses like real hardware components. So like edge devices, real communication devices, and so on, so that we can actually test and try out different approaches for Forestry 4.0. And the idea is, to have something you can actually play around with and so come up with new solutions and new ideas. And if you have a solution, then provide a nice and easy way to test if your solution might actually work. So such a model is really tangible, it's touchable, you can actually play with it. Let's have a look at the real machines now. So I was talking about digital twins, how we actually provide one of these forest machines with a digital twin. So these big machines usually have like onboard computers. And to actually add a digital twin to one of these machines is pretty straightforward when you just add an app to this onboard computer, and this app can then actually like collect data and send the data and connect it to other machines. How about machines that do not have like a board computer? So one way to actually do this is to provide the digital twin in a cloud infrastructure. Another way would be to actually add a so-called edge device to one of these machines. And what can these edge devices do? They can collect information about positioning with a GPS, for example. They can connect to external sensors, collect the data and process the data, and then communicate with other digital twins. What about machines that do not even have sensors? So for these machines, you actually have to add like some sensors to actually get out some interesting and important information. So in this case, we have a mini tractor that we use in manual felling operations. And we added some sensors. For example, you can pull out a rope here, and this sensor tells us how long the rope is pulled out. We have another sensor that tells us the current state of the motor. And all this information is processed and sent out again with one of these digital twin boxes. Okay, so but infrastructure is not just like digital infrastructure and infrastructure like real hardware infrastructure. Infrastructure is also like a partner network. So we have a network of companies, mostly from Germany, where we have some international partners too. And if you're interested, just join us, contact us as info@kwh4.0.de. There's also a website, www.kwh4.0.de, but be careful, information is currently only provided in German, so that might be difficult for some. Okay, this is basically it. Thank you for your attention. I wish you all the luck for the rest of this interesting conference, and I would like to give back to Thilo. Thank you. Thilo, you're muted currently.
Yes, okay. Thank you very much, Frank. Are there questions to Frank Heinze from the chat or from the audience? Please feel free to question him.
Yeah, don't worry. Even some of the concepts might be complicated. If you do not understand them, don't worry. I'm basically free for any type of question, even if they might sound.
I have a question, Frank.
Okay, go ahead.
I think it's an excellent infrastructure project, and technical challenges needs infrastructure. What do you think? Could it be this center of excellence for Forestry 4.0 a good blueprint for other countries going the same way, for example? And what are the backbones, for example? What are the difficulties if you try to build up such a network?
Yeah. Basically, I think it would be a very good blueprint for other countries. And well, what is usually difficult for us, we found out that even if we think that there is some kind of digital infrastructure, it's still difficult that you actually share your data with other people, and on the other side, keep your data in a way that no one who is not allowed to see the data is kept out. And our current digital infrastructure makes these concepts, well, at least challenging. And we hope that with some of these Gaia X concepts, we will come up with easy solutions that can then be imported into other countries too. Yes, because the basically idea of Gaia X is to have an open infrastructure. So it's not something we develop in Germany and in Europe and we keep for ourselves. So it's basically an open system with an open description how it works. And so people from other countries are actually invited to hop on board. So we have questioned what could it be?
Yes, Frank, we have a question, and we are working in the competence center at a lot of different solutions for forestry. And the question is, what could be is possible application in land restoration and biodiversity conservation sector?
Okay. Well, in land restoration and biodiversity conservation sector. Yes.
I think the things we are doing with water, for example, and this,
yeah. Okay. For example, we built up a sensor system that's actually monitoring the current state of our forests, and currently these types of sensors are pretty rare. But if we would like to take care of our forests and actually keep track of what's going on, then we actually should have a good monitoring system of our forests, and so also monitor how biodiversity in our forests is developing. So, for example, one of the sensors in our sensor system actually monitors sound, and sound can be related to biodiversity. So if you have, like, for example, birds in the morning in the forest, this is usually a good sign that your forest is in a pretty good shape, for example. Yeah. So these digital infrastructure can also be used to monitor biodiversity and to help to support knowledge of our forests.
Okay, thank you very much. Other question. Please feel free to discuss and to ask. There is some. Are the future challenges to the climate change also considered, for example, by using forest modeling with different climate scenarios?
Yeah. Currently, some of our next projects will actually monitor CO2 in forests. So usually, we think that our forests take out a lot of CO2 out of the air, but on the other side, some of the production processes actually also produces CO2, and we would like to actually monitor more closely what is actually the net result of all things done in forestry, and then if we have more data, that actually helps us. And important is also, for example, to have data for deciding how the forest is actually developing. So which trees to plant. I'm not an expert in this, but you need a database for this. Yeah, you need information, and you need climate models, and you actually, for these climate models, you need data infrastructure to actually provide these models with with appropriate information.
Okay. So if there are no questions anymore, we will go on with the next interesting project. International cooperation is needed for the challenge of digitalization in forestry, and it's very necessary to share know-how with a wide impact. In case of the project Rosewood 4.0, the wide impact was 21 partners from 18 European countries, and the project was finalized in summer with an event at EFI in Barcelona, but it still goes on because we have some very interesting results. And about the project and the results, now Daniela Saric-Bartolovic, which is the head of Department for Programs and Projects in the Competence Center for Research and Development from Croatia, will report about this interesting project. Daniela, the floor is yours.
Thank you very much, Tilo. Just give me a second to share my screen.
The microphone is closed.
Sorry, just the usual technical issues. Okay.
Now we hear you.
Okay. Oh. Give me one more second. Just I will close the unnecessary presentation. Okay. Okay. Tilo, can you see my presentation?
I don't see the presentation, no?
No?
Not yet, no.
No.
Okay. And now?
No.
Okay, something I'm doing. Yes. Okay, what about now?
Okay, now it works.
It works?
Yes.
Okay.
No, no, it works for a moment, but not now. We see it for a moment, but it changed back.
Hold on. Okay. And check. Okay. This one. Oh, sorry. No, it's not working.
So if does not work, Daniela, it should. Now we see it.
Good. Finally, I apologize.
Okay.
It seems that I wasn't a good listener during the hopping, the 1 hour session that we had to instruct us how to work in this application. I apologize one more time. Hi, hello everyone. My name is Daniela Čarić-Bartolović and I'm coming from Croatia, from Competence Center. It's my pleasure to support this initiative, which is primarily enabling young people to exchange knowledge and share information. Hope this Rosewood 4.0 presentation will be useful for your further development. Allow me to introduce Competence Center with a couple of words before we start with the presentation of Rosewood 4.0 project. We are a fairly young company established by Vukovar-Srijem County for promoting smart and sustainable natural resources with a mission to strengthen potential for advanced, competitive and climate neutral economy. SECOM is focused on implementing development, production and research projects aimed at green transition and digital transformation. And during last 5 years, we gathered some experience in implementing projects funded by European and national funds. So within Rosewood 4.0, we were hub managers for Southeast Europe hub. Rosewood 4.0 full title of the project was European Network of Regions on Sustainable Wood Mobilization Ready for Digitalization. And it was a Horizon 2020 project funded by Horizon 2020 program, and the continuation of first Rosewood project used as a basis for building this new network of multiple actors along the forest value chain to reinforce the sustainability of wood mobilization in Europe. So Rosewood 4.0 put a special emphasis on digitalization and digital tool for training and coaching, enabling practitioners to share know-how with much wider impact. So focus was on ICT sector and focused and addressed two main challenges in wood mobilization. First one was better access to resources through the defragmentation of forest properties and increased volume to market with higher transparency. Rosewood 4.0 gathered 21 project partners from 18 countries and organized in 5 regional hubs. Project was directed to enhance actual Rosewood EU network of regions, allowing stakeholders of wood mobilization value chain to connect and share best practices on the field. So final aim was to efficiently transfer knowledge within and across regions through modern tools such as digital platforms and digital training solutions. Within Rosewood 4.0 project implementation, 459 examples of best practices and innovations were collected and deposited on an open access knowledge platform. At the audio-visual section of Rosewood 4.0 project website and YouTube channel, you can find 25 video productions related to best practices and several virtual study visits, which were organized during the implementation of the project. Gathered best practices cover social technical innovations, business practices, companies, pilot projects, research and education programs, and all other segments of forestry wood value chain. Emphasis have been given to digital domain and digitally supported solutions. Within Rosewood 4.0, two results were identified as main results. One is Rosewood 4.0 network, and the second one is knowledge platform. For knowledge platform for regional forest innovation, and these two results were insurance of the project sustainability. And regarding this network concept, project partners indicated all project partners indicated interest to continue with engagement in the networking and dissemination activities, as well as collection of additional best practices and innovations in sustainable wood mobilization. So knowledge platform represents easy access to usable information in a form of fact sheets, highlighting outstanding practices and innovation in forestry from more than 15 European countries. Open access repository contains multilingual fact sheets, videos, additional materials, and of course contact details, so you can get in touch with best practice owner and find out more information if needed. So please feel free to visit Rosewood 4.0 project website and check out what can we offer there. Rosewood, the network was established during the final conference of Rosewood 4.0 project. As Tilo mentioned, that was held in Barcelona in beginning of summer this year. And from the 1st of July, Rosewood 4.0 network continued working on voluntary basis with contribution of all project partners who committed themselves to continue with all network activities. Rosewood 4.0 network is, as I started explaining, dedicated to identification of new best practices and innovation, and is dedicated also for all the future possibilities of cooperation. For example, preparation of new project proposals for EU funding programs. We are coming from Europe, so EU funding programs are, let's say, the primary focus. Network is also possibility and good base for discussion and exchange of further relevant information. So either international, national forest events, new initiatives, new project proposals, any relevant information for foresters and related for stakeholders are or will be exchanged. Network is open for all new members, so if anybody finds an interest to participate or to join, please do not hesitate to contact us. One other thing that members from the network decided to regularly provide is the newsletter. So the first edition was published at the beginning of November. We dedicated, we decided to publish 3 newsletters per year. And of course, if you have any information that you think that would be valuable to other forestry stakeholders, please don't hesitate to contact us and to share inputs for new newsletter edition. Additionally, this platform basically had to be fed. So collection of additional best practices and innovation will be performed through minimum 2 examples or 2 fact sheets per year by each member. And it is fixed to ensure the continuous feeding of this knowledge platform. Each partner will be responsible for adding a new best practice, as well as preparing the fact sheets in English and native language. So that's why when you visit the platform, you will see numerous languages, and everything is prepared either in English and native, or at least in English language. Additional feeding of this platform is also will be also the online repository of 2 other thematic networks, Incredible and Affinet. Go Forest is the project which will be implemented during next 3 years, and it will take into consideration the Rosewood knowledge platform also, and we'll try to build upon all the results achieved during the implementation of Rosewood 4.0 project. So once again, it would be great if you could take some time and check out our website and see all the information that we have to share. Now, Tilo, I will stop sharing. So let me come back to, now you can see me. Okay. Hope these technical issues didn't make a mess from my presentation, and you could see everything the way.
No problem, Daniela. We could hear you excellent, and we could also see the presentation. Everything went okay. Yes. So there are questions to Daniela.
Okay.
Please.
Nothing for now.
Nothing for now. Uh, Daniela, what is the feedback of this offer we give, this overview about the digital current status over Europe? We have a good project website during the 3 years lifetime of the project, but now the knowledge platform starts officially after we finalize it with the present with the final meeting now. And so it's since summer we offered as partners this platform. How is the feedback all over Europe?
Basically, we have very good response, especially from other networks and other projects, because this one-stop base is a really good start for either investigating what's new happening all over the Europe. We have even some projects from Canada, from US. So it's a great platform to share knowledge, and it's open. It's free of charge. You open access and free of charge. Um, uh, Basically, pool of information related to, as I mentioned during the presentation, really diverse topics and diverse backgrounds, not to mention countries, but from companies, from projects, initiatives, really wide spectrum of topics and sources of information.
So we have on this platform different offers. We have training opportunities, we have best practice opportunities, we have information about other projects, also in our
Yeah.
newsletter, and also with the various applications of digitalization forestry. What is the most wanted aspect on the platform?
Um, oh, well, I'm not sure that I have that answer. I think, according to information that we have from European Forestry Institute, which is handling the maintenance of the platform would be the best practice and the innovation platform would be the most used result from Rosa 40 project.
Okay. There is one question. Is there an action plan to take it to the foresters for them to start using the platform and make some changes?
Well, we during the project and now during the within the networking activities, definitely all partners expressed the interest to introduce this platform to foresters and to other stakeholders also. So dissemination activities are one of our main ones in order to get them familiar with possibilities that we offer and when with information that they can get in one place.
Okay. So, are there other questions? Okay,
It seems not.
no question anymore, but I think in your presentation there was the link to our knowledge platform, and
Yes.
I advise all the people, our audience, to go there. I think it's very interesting, and it's a very a good project to get an overview about digitalization activities in Europe, and also the training activities are quite interesting.
Yes, definitely. Within the website, there's a link for
Yeah.
training materials. There's a knowledge platform link, so you can access through the website. You can access
Okay.
everything.
So thank you very much, Daniela.
Thank you.
Let's go to our next presentation. So we are talking about highly mechanized timber harvesting and the possibility to make it much more digitalized with um, with autonomous or semi-autonomous assistance systems. And there is a very interesting technical research project, also a European project. It's called Avatar. And Florian Hartsch, with his research associate at the University of Göttingen and at the States Forest Service of North Rhine-Westphalia, will now report us about this interesting project. So let's go, Mr. Hartsch.
Thank you, Mr. Wagner, for the introduction. I try to share screen now. Okay. Can you see my presentation now?
Yes.
Okay, great. So hello everyone again. Welcome to the session from my side as well. My name is Florian Hartsch. And what I will present you today is the Avatar project, which we just finished in the end of October. And it's a quite interesting project because it's related to digitalization in forestry and also related to highly mechanized harvesting systems. So firstly, we need to be aware about the background in which we deposit this project. So as you can see on the pictures, this is quite sad, but it's a typical situation for Germany at the moment, that we have large areas of forest which died in the last years as a result of droughts and a lack of precipitation. And what we realized again is that we only can face these challenges, these large amounts of timber. We can only face this with highly mechanized harvesting systems, which means that we only can use harvesters and forwarders to fell and process and forward the timber out of the forest due to efficiency, of course. And the second point is that these highly mechanized harvesting systems are much more safe for the person who work in the forest. If you imagine, we can't process these stands with motor manual loggers. It's just too dangerous for them, and that means that we need to use this highly mechanized harvesting systems. When we take a look at the forest machine operator workplace, then we can assume that it's a really heavily complex work. So that means that we have long and intense training programs for forest machine operators in Germany. We have also at the State Forest Service, at the Forest Education Center, we offer courses for young forest machine operators to train their the way to operate the machine. And these training programs are intense and long. And the full aptitude of the operators is only reached after 3 years. That means that you need quite much time to perfectly operate the machine, because it's just really complex. What we can assume is that a harvest operator fells and processes up to 2 trees per minute, which means that he's doing 12 decisions per tree along an 8 to 10 hour working day. Per hour, a harvester operator or also a forward operator does up to 3,500 joystick movements. And all this means that we have a high cognitive strain on the operator. And this also means that we need to act there. And this was actually the goal of the Avatar project, to improve productivity and job satisfaction of this forest machine operators while reducing mental workload. And how did we want to reach this goal? We developed a digital coaching, assistance, and feedback system for forest machine operators. As you all know, digital assistance systems are quite common in automotive industry already, but we were one of the first ones who tried to implement this or implemented this in forest machines. How do we get started, or how did we get started? When we want to develop assistance systems for operators, we need to firstly, of course, aware about work practices. So that means how does actually an operator work in the forest? The work practice is a kind of individual way to operate the crane or drive the machine, so individual way of carrying out work practices. And to find out what these work practices are, we conducted interviews in Germany, Norway, and Sweden. In Germany, for example, in four forest education centers, in Norway and Sweden as well. And we get in touch with forest machine operator trainers, because we assume that these forest machine operator trainers have a quite deep knowledge about all of these aspects on work practices. What we found out in this complex and intense interviews was that we can found disadvantages work practices in crane work, in positioning, and in work organization. And this means that we have already some points where we can say, okay, here we need our assistance system for the operator. What we also did is we conducted several field studies in which we evaluated time consumption per loading cycle for forwarders. You can see it on the y-axis, and we differentiated now between different loading angles, because as you all know, when you drove or when you drive with the forward hand to the stand, different loading angles and also different loading distances arise. And what we found out is that we have, depending on the machine, of course, but and on the range of the boom, but we found out that we have, of course, optimal loading ranges, and this gives us some implications for the precursory work of the harvester, for example. That means when we have an optimal loading range from 4 to 6 meters, we can give advices to the harvester operator to say, okay, please try to deposit the wood piles not so far into the stand, deposit it directly next to the machine operating trail. And these are all aspects we use or we can use in this assistance systems. What we also deal with is with the identification of advantages and these disadvantages work practices in forest machines. And what we also did is to develop algorithms to detect work elements, because as you can see here, this was a simulation by our project partners from Sweden. They simulated the work elements, and this is quite important for us because we can use the results of this time studies also in the assistance systems. How these assistance systems look like, I will show you later. The next step was to detect, to quite intensively detect the work environment of the forest machine, because when we say, okay, we want to develop a system which helps the operator while positioning, the operator on the harvester or the forwarder needs to know where he actually is in the stand. And that's why we equipped a harvester with a sensor platform. We had different LiDAR sensors, so laser scanning, and the result is you can see here a point cloud, and when you use SLAM algorithms, you can change these point clouds to detect the stems and the trees around the machine. You can see it here. I will show you later a more detailed picture. What we also deal with is to evaluate existing operator assistance systems to support the operator. As you may know, in modern forest machinery, we can use rotating cabins. So the cabin is always, when you activate this function, the cabin is always following the boom tip, which, based on the view of the manufacturers, which is more ergonomic and more efficient then. And we also have this intelligent crane controls. This basically works like this. You have sensors in the hydraulics, and parts of the crane operation are automatized. So that means that in this intelligent crane controls, you don't need to operate the boom tip anymore. And yeah, we tested this, of course, and what we found out is, you can see it here on the in the plots. On the y-axis, we have the time consumption per loading cycle for a forwarder, and we tested 4 different variants. For us now, interesting is just the right one and the left one. On the right one, we can see a reference variant with 150 testings or repetitions. And this is when we deactivated this intelligent crane control and the rotating cabin. And when we activated both of the operator assistance systems, we found out that the time consumption per loading cycle could be significantly reduced by up to 14%. And this is a quite big improvement for efficiency of the machines. And we can also use this information for our assistance system. What we also deal with is to use generally best practices in highly mechanized harvesting systems. As you all know, these harvesting systems are quite optimized, but we need to use new techniques or programs or software to support the operator more. So that means that we also integrate this forest machine simulators in the teaching at the Forest Education Center, because there are studies existing which say, okay, the operator who's learning these activities to operate the boom and the machine, the success of learning is the same when you start the first weeks on the operator, but the danger to damage anything is much more decreasing, of course, because you don't work with a real machine. And after a few weeks, the operators would go on the real machines and then start practicing with these. Of course, mapping software, which is quite interesting for us at the moment. You can use this mapping software for harvesters for the operator to know, okay, which trees are marked here in the stand. This is quite interesting when you have several areas where you have marked trees, but these areas are a little bit not next to each other. And this is also interesting for the forwarder, of course, because the forwarder can plan before the operation. Okay, we have 60 cubic meters here and 50 cubic meters 100 meters away, and this is much more better for planning. And these are all aspects we integrate in these operator assistants. And of course, the last point, the development of new assistance systems, which we did in Avatar, is quite interesting to improve these work systems at all. So these are the slides to show you how this assistance system works. You all remember the slide on the sensor platform. So what we did is to equip our harvester with the sensor platform. You can see it here. And what we then did is to integrate a head-up display into the cabin of the harvester. That means we work with augmented reality, which you can support the operator work with augmented reality with some more information. And the head-up display is the medium to show the operator some more information. As you all know, the operator has also his board computer for cutting and processing of the timber, but we also have this head-up display now, which is quite interesting for positioning. This is the result of the Avatar project. What you can see here is the view out of the cabin into the direction of the crane, and we have here this head-up display, and we actually were able to show the operator the machine. This is the white one, and two ranges. So based on our field studies, on the time studies, we could say, okay, we have an optimal boom range from 7 meters, depending on this machine, and a maximum working range with a boom of 10 meters. And that's what we can display. What we can also display is the position of the aggregate and the position of the trees in the nearer surrounding. And that means that the operator now is able to get supported while positioning, because positioning is decisive for efficiency of highly mechanized harvesting systems, as you can imagine. And that's what we were able to show with this Avatar project, that operator assistance with head-up displays is possible, and that it can also be a big benefit for the operator. These are the references if you want to have access to it. As a last, I want to shortly sum up that, as Mr. Wagner said it already, that this Avatar project was on an international level. I think you all should know at least NIBU and Scopeforce, which are in forestry, forest science, active in forest science, but also the State Forest Service of North Rhine-Westphalia and the University of Göttingen. We also published several of the project results. And most of the papers is open access, so you can you can have access to it and check the results. And yeah, I guess that's basically it. I stopped screen sharing. Thank you very much for listening. And yeah, now I'm ready for the second part, of course.
So thank you, Mr. Hatch, for this interesting presentation. Questions to Florian Hatch? So I have one question also. There's also one question in the chat, and the question is, you report that you are working in an international, well-acknowledged consortium in this subject. You are working with sensor technologies, with head-up displays. What do you think how highly mechanized timber harvesting looks like 10 years ahead in the future? Will be it semi-autonomous like today, or will it be completely autonomous without operators like forest harvesting robots, something like this? What is your opinion about this?
Thank you very much for this interesting question. What we can assume is that we not easily can compare autonomization in forestry with autonomization in automotive industry, for example, because in forestry we always have factors which we can't influence. Depending on the operation area, we have different slopes, we have different micro topography, and so on. And this means that we probably won't ever have a fully autonomous, highly mechanized harvesting systems. That means that we need to focus on this operator assistance. You can use robotics machines in automotive industry, but in forestry, it's on my opinion, too difficult. And that's why we need to focus on this operator assistance, in which the operator, of course, benefits the most, I would say.
Okay, thank you very much. There is a question from the chat. Is this system economically affordable for the medium-sized forest enterprises, or is it only for the biggest companies?
Okay, thank you very much for this question. I think you aim for the economic affordability of this intelligent crane controls and rotating cabins. And what we can assume is that yeah, the amount you need to invest in these systems is not really high. It is possible for medium-sized forest enterprises to integrate these systems, but at least medium-sized forest contractors in Germany who operate harvesters or forwarders or maybe only one machine, they say, okay, I use this machine until it's quite broken. But after it, when they say, okay, we need to buy a new machine, the new machines are equipped with these systems, and these systems is state of the art. And in several years, I would say we won't see many harvesters and forwarders without these systems. Of course, it will take some time to equip all entrepreneurs and forest companies with these systems, but it's the state of the art. And in several years, every machine will be equipped with it, I would say.
Okay. Other questions? If there are no other questions, we will continue with our next presentation. It's about business challenges in Forestry 4.0, and the world market leader for chainsaws, Stihl, thought a few years ago about certain technical developments, and so they found a spin-off company who was developing a digital solution. And now it's a best practice for forestry wood startup. But Mr. Stapel, it's not a startup anymore because your company had also a history. It was one of the pioneers for the digitalization also in Germany. So Mr. Bertil Stapel, the sales manager from Treva Company, will talk about business changes of companies in forestry. The floor is yours, Mr. Stapel.
So thank you very much. I will start screen sharing. Second. So you should see my screen now.
Yes, okay, we see it.
Perfect. Good. So I will show you some examples how we use our software to digitalize the forest and the timber supply chain. You can see it as an example what you can do in the forestry, and maybe also with a degree in forestry, for example. So that's also my background. I studied forestry in Göttingen. I worked a couple of years for the headquarter of steel, the world market leader in chainsaws. I think nearly everybody who is here knows steel. And after a time, I changed to the corporate startup, our Triva company, and now I'm here nearly 3 years now with this company as a sales manager. So who we are, it's correct. We belong 100% to the steel group, to the steel company, to the headquarter, and you could call us a startup. It's correct. We are not a classic startup. It's more a corporate startup because we have the big steel company behind us or with us. What we do is we develop a program and sell forest management software. We started with 2 different products. First, it was Logbuch. Logbuch is a product to locate objects, I would say, in the outdoor. The object is here, what we see now, or we're talking about mainly the tree trunk, but could be also anything else in the outdoors. We have a mapping system behind it. We will see some examples later. This helps for job management, like for the harvester, to send him the trees he should take down on harvest, for example. Then we have a second system, the Forestry system. It is a photo-optical measurement system, you could say, to measure wood piles. We put both systems now together, that we have all the advantages of both systems in one, and this is Triva. I will show you in a few seconds. So let's have a look back. What is digitalization right now or in the past? We work for a couple of years with computers now, even in the forest, but we have a lot of breaks when it comes to the media. And we often work with pen and paper in the forest, and afterwards we bring the paper back in the office, and you need to put it in an Excel sheet or something, and there's a break. Also, we work with a lot of maps in form and in a handheld map as it's really a paper map and not a digital system often. And also, when we are talking about the harvesting, we use in a quite amount also still chainsaws, and there is something digital with chainsaws. When you have a new chainsaw, there is for sure the carburetor is digital often, or it's digital controlled. Also, we have a fuel injection and so on. But this is nearly everything what is digital with the harvesting when you use a chainsaw. And this is what we see and where we take our part and use our software. I will show you later how that works. So what is the challenge, or the challenges in the forest for us, or in general for the workers and the foresters? So we have a lot of requirements when it comes for the work orders. There's a high amount of coordination behind that. You need to show the area where they need to work, and this is often that you go out on the one side appointments for the instructions, and often you go a second time to the place and talk with them about the work. Also, what I showed you before on the picture, we have the manual transfer of the information and the data into a computer system for billing and for logistics. And also all these information afterwards are often used or transferred with handwritten notes as well and maps. And so this is at the end, we have the media disruptions with this data acquisition. So the first thing is we start with the locating of things, trees, with a digital system. We are using an app, a smartphone app, or you could also use a tablet. We don't care. Android or iOS is also available. For the data acquisition, we use smartphones. How we do it? We do it with text to speech. So you don't need to take your smartphone in your hand. We use a small button, a Bluetooth button for the recording. You start the recording with a push of the button, and you stop the recording with the push of the button. And at the same time, we take the GPS position, and everything is in the box. To just say what is the type of tree, what is the diameter of the tree, and everything else you want to put as information to your place mark, just with text to or speech to text. And then you see here the app. There you have a lot of different categories, and you see immediately what this point is for a category. Like it's a tree, it's a wood pile, it's a road, or anything else. This information is then shared with others in the forest, for example, with the lumberjacks, that they know where to find the trees. This is all in one system, so they can also navigate to the trees. They find faster the area where to work, the tree itself. So we reduce the amount you need of time and reduce the time consuming using of maps, if you want to say that. It's like a navigation system also. And this at the end saves time and money, because I don't need to talk to the forester, for example, again to show me the trees where they are. They are also often marked for sure, but sometimes we have a lot of vegetation. It depends on the season we have, and then you can't often see the marked trees. But if you're next to them, maybe. But if you see it here in the digital system, you see, okay, there's another tree I need to take down. So also when we see the logs, when they are felled, the trees, we have the opportunity to give all this data in a fast way into the system by typing or by text to speech. You can work nearly hands-free and put all the information of the tree trunks in the system, and it's ready for billing. Here you see an example for single logs. We don't work with anything else than the smartphone. Like I told you, you put everything inside, the number of the log and the length, the diameter, which tree species is, and so on. And with one press of the button, it's digital in the system and can used for the next steps. Also, we have the opportunity to measure wood piles by using the camera of the smartphones. You don't need to have a special smartphone or tablet. It would be good if it's a newer model, that you have minimum 3 gigabyte of RAM, but it's not important if it's Android or iOS. If it's not older than 3 years, we say normally it's capable of doing this measurement. And how do we do it? We take several pictures, like on this screenshot you see here of the wood pile, and have afterwards we have a panorama picture we put together, and with the AI we measure the wood pile itself. Afterwards we have the web portal, where you can use just a web browser from every computer to see the collected data, to manage the data, and to do exports, imports of maps and other stuff. There you see here the list you can have. We have also a map and so on, and deeper stuff for sure. So at the end, we have a lot of advantages with the system, that we navigate easier or faster to the area where we want to work. We have improved communication with all the information you just give in the system by text, by speech to text. This is also a time saving and cost optimizing part. And at the end, we increase the quality of the results you put in the system. And for sure, don't worry, the system works completely offline. And with standard smartphones, and you don't need more than just a smartphone. And so you can use it nearly everywhere in the forest, and don't need more. So that was it. I'm open for your questions, and I'm interested questions.
Thank you very much, Mr. Stapel. And so it's open. Do you have question to Mr. Stapel? Okay, I have a question. What advice? There are young people who are listening to us and see us and watching us. What advice could you give them if they have a good idea for digitalization in forestry when they want to found a startup company?
Yeah, you need a good mock-up. You need a good pitch. You need to talk to the right people. Yeah, that's for sure the easiest answer, or the easy part of the answer. At the end, you need to think out of the box. Like what we do here and do in the future is we just use standard technology. We use the smartphone, and nobody thought about things like that. We have sometimes special hardware and so on. Think about using what there already is, and often the easy solution is the better solution than a complicated solution. Just try to think of the start of a new start. Yeah, take just a plain white paper and think about the idea what you have, and work on it.
Okay.
Work on your dreams.
And there is one question. Is it just for forest inventory, or is it for calculating biomass or volumes?
Yes.
And what is the cost for the forester to use it, rather than him going with an iPad and the Excel sheet open?
So it is. So there are some questions. It is not only a tool for the forest inventory, or it's not really a tool for the forest inventory. You can use it for forest inventory. It's more for, and that's correct, for calculating biomass and volume. This is what the system does automatically when you give information like tree species and the diameter of the tree. We can give you the biomass you want to harvest. And for sure, you can use this for the forest inventory. At the end of the day, we see us more as a job management software to arrange everything, every work and everything in the forest, not just cutting or felling, also for nature conservation, like locating of important trees and habitats. We need to have this digital to show where everything is and to find it faster, to be more transparent. It's not only for harvesting.
Okay.
Another question: what is the cost for the forester to use? Yeah, this depends. It depends if you need 1 apple or 20 apples for sure, but around about you start with 500 euros, and the premium license for one forester is with 1,500 euros each year. The software is a service, and it's an abo model, license model.
When we talk about digitalization, mostly we are speaking about high mechanized logging. And you mentioned there's also digitalization in the motor manual mode. That's right. So we have the fleet management systems, for example, from the chainsaw manufacturers. What do you think will be the next hotspots in digitalization in motor manual felling? So the smart forest worker.
It's more a help, a guiding system to find the spots, more easy without taking or have more work or more effort, like maybe head-up displays and stuff like that, or also audio, which helps you to give you directions, and you use a microphone with your helmet to put data into the system, and that's not the future, that's already here, but this is improved and will be much better in the future.
Thank you. There is also one question left to Florian Hartsch, and so it's about the economical value of the technical solution. Can such systems reduce wastage in the resources while harvesting?
Yeah, so I think you should hear me now. Thank you very much for this interesting question. Of course, we can reduce wastage of resources, because if you imagine that we have efficiency improvements through these systems in highly mechanized harvesting or logging, then we can say, okay, the amount of resources we need to produce 1 cubic meter of timber is decreasing, and that means that we have, of course, a decreasing wastage of resources, fuel, and so on.
Okay, thank you. So just a final statement from our colleagues. It's about the digitalization from the perspective of people working in the forest. According to the International Labour Organization, ILO, they're speaking about decent jobs, which involves opportunities for work that are productive and deliver a fair income, security in workplace and social protection for families, better prospects for personal development and social integration. What do you think is the contribution of digitalization for this decent jobs for the future? What is your opinion? Just a short round. Maybe Frank, you started.
Okay, so digitalization for the forest worker, I think it's a big chance. So it might make your job even more interesting, and it's basically may also help you to make your job more productive, but on the other side, more more secure for the future. If you have this digital knowledge, this might be a real advantage for you in your job, even in forestry. So I guess forestry jobs will become more and more digital in the future.
Thank you very much. So, Daniela. Daniela?
Yes, I'm here. Well, I think that definitely digitalization is something that no sector can function without, and forestry is also. And the shift of generations, inclusion of younger people in forestry sector will definitely contribute to digitalization of the overall sector, and the usage of smart technologies or new machinery in everyday job will be more present in the future. Maybe this traditional way of functioning in the forestry sector is shifting, and definitely digitalization is great opportunity for overall modernization.
Thank you very much. Mr. Hart.
So thank you very much. When we are talking about digitalization in forestry, we need to, of course, as Mr. Heinze and Ms. Bartolowicz just said, we need to, of course, be aware about that. Digitalization is a quite good thing, and from my perspective, when we have a view on logging, either highly mechanized logging or motor manual logging, the digitalization enables us to make this work more efficient and more safe. Yeah, because forest work all over the countries of the world is one of the most dangerous jobs, and therefore we need to find ways to improve work safety and also efficiency, and digitalization therefore is a great chance for us, and that means that we of course need to focus on it more and more in the next years.
Okay, thank you very much. Mr. Stapel.
Yeah, so digitalization doesn't mean that we need less people in the forest at the end. We need people who wants to work with these tools, and with these quite easy tools. It will develop in a different way. It will make the jobs more attractive. It will not just be, I will take simple, like just to say a chainsaw and the axe anymore. It will be more with other systems. This helps us at the end to have a better planning, a better overview, and to have a faster reaction when we see the last years with a lot of calamities in our area here in Europe. We have with digitalization more the possibility to react faster and maybe better in the future. And this is a big chance for all of us.
Thank you very much. Are contributions here from our audience from the net also? Okay. So, a final conclusion at the end. Digitalization represents a social and a business challenge that raises expectations, both positive and negative. We have to accompany this for the forest industry, and it's not a national, it's an international challenge we have to do. We have open questions. For example, who is the owner of the harvester data? The legal position is not quite clear. Is it the manufacturer, the entrepreneur, or is it the forest owner? What is the value of the service of providing data? It's about data economy. The fleet management systems of the chainsaw manufacturers are providing a lot of information. So we had the class forest worker, also the smart, but also the class forest worker. What about traceability, personal rights, and data? These are also interesting questions and problems to answer and to solve. This will be the task of the future. And dear audience, it will be your task in the future. And I think that's an interesting challenge. So from my side, thank you very much for the speakers, for their interesting contributions. Thank you very much, dear audience, for taking part at this session. It will be repeated in the afternoon. Also, if you are interested, you could visit us again in the afternoon, no problem. Thank you very much, and also a nice, interesting meeting. Thank you very much, and goodbye from Germany.
Thank you, Tilo. Thank you, everybody. See you in the afternoon.
So, okay, thank you very much, and we will see you in the afternoon. And so, I think it was a nice session. It was interesting, and so we will continue in the afternoon. See you. Bye.
Thank you. Bye.
Bye.
Okay, bye.
Yeah, I remember to the audience and also to the speakers that you can go to the networking part of the Open, so you can interact with the rest of the attendees. Thank you, Tilo, for organizing this very interesting workshop on digitalization in the forest sector. I am happy that we maintain the audience equal or greater than 35 attendees during all the session. So it's a really good number. Thank you again, and see you in the afternoon.
Yes. Thank you.
Pleasure. Bye.
Okay, see you.